Hey guys, what's up? This is HBRC here, and today I'm going to be doing something different. So I'm going to be doing a bit of a build video today, and as you can remember, well, this is what I put in my description. A few weeks ago I was using this, which is the NAS 32 board, and this is an F1 board, which means that the gyro inside the board is running at 1 kHz, and the PID loop in the board was also running at 1 kHz. And now this is a pretty outdated board, and Betaflight have actually stopped releasing updates for this board. So yeah, this is just pretty outdated and it's quite slow now. And so in my last video I finally got this, and this is the new Matek F4 board. And so this F4 board runs at 32 kHz for the gyro and 16 kHz for the PID loop. This also has the ICM 2060-02 gyro in it, which I believe is one of the most advanced gyros on any flight controller these days. So this also has the OSD chip here, which means I can now use the on-screen display in Betaflight, which is really good. So now I can see how many amps I'm drawing and the voltage of my battery when I fly. I can also use black box logging now because I have a space for an SD card in here. So this board connects to my PDB using this little ribbon cable back here, and so it just goes in through that little port there. Now this makes wiring quite simple, so no actual signal wires from my speed controllers actually have to go to my flight controller. So as you can see, I've also wired up this little cable to the S-bus port here, which means I am now finally using the Frsky receiver. So this is the Frsky-XSR, and this weighs only 3.8 grams, which is a lot lighter than the older ppm receiver that I was using, which was actually 11 grams. So now I'm sure you all want to see what this is. So here I've been working on a little project at school, college, and at my college they have a 3D printer, so I decided that I should make a 3D printed drone frame. So this is just a prototype at the moment. It took me like a month or two to sort of design this whole thing, and I was using Fusion 360 to design it. And so this is what I came up with. So these are the arms, or these four here. This is the bottom plate that my battery strap goes through and the arms attached to. This is the middle plate that goes sort of on top of the arms, and this is the top plate. So these arms are 6mm thick, and the actual bit where the bolts go through are 4mm thick, so I don't have to buy new bolts. And these are actually pretty durable, and I can apply quite a bit of force here and they don't really seem to bend. And even if I'm sure it'll be a lot stronger when I put it on the actual frame. So I'll just show you how this thing goes together. So I'm using these M3 screws to go through the first hole here, and these are going to go through the arms like that, and then up through there. And these M3 screws are going to attach to standoffs, and these standoffs are going to be attaching the middle plate, which is where all the flight controller will be and the PDB will be mounted, to the top plate, which is where I'm probably going to put my camera and my VTX. So there's also this, which is another M3.5 bolt, which actually goes up through the second hole here to hold the arm in place so it doesn't swivel about. And I've also made these holes here, and these are what my battery lead is going to go through, and this is going to make wiring a lot simpler, because now when I put the whole frame together, my battery lead can just come out the bottom like that. So I'm going to now put this whole frame together and show you how it looks, and then in a separate video I'm actually going to build the whole frame, and I'm going to be using all of the electronics that I have on my RAG-E frame at the moment. So this will be quite a big upgrade to the RAG-E frame, because obviously this is much lighter. The RAG-E frame weighs 125 grams yet, and I haven't got like a proper weight for my 3D printed frame at the moment, but as an estimate I think it weighs less than 80 grams. So I'm going to get a proper weight at some point, but I just haven't weighed it yet. So what I'm going to be using on this frame is I'm going to take out all the electronics from the RAG-E, and I'll probably be changing out these motors, because these aren't a very high kV at the moment. So these are 2300 kV 2204s, and I'll probably get like 2500 kV motors to put on this. So yeah, let's do that now.
I don't need no dreams when I'm by your side. Ooh. Every moment takes me to paradise. Darling, live in love. I won't give you reason to change your mind. I guess it's still you tell me, baby. You are all the future that I desire. Girl, I need you. There'll be no more mountains for us to climb. I guess it's still you tell me, baby. This will be a
Okay guys, so here is the whole frame. Obviously this battery lead is going to have to be cut down so I can solder it to the PDB. I still need to drill some holes to put the camera through, the FPV camera obviously, and my HD camera is probably going to go on top of here using this little 3D printed mount that I bought. So yeah, this is pretty much the whole frame, and I don't think I mentioned earlier, but this frame can actually swing bigger props now. So the Raggy could only swing 4-inch props, but this can do at least 5.5-inch props. I think it can just about do 6-inch props, but they almost slightly touched last time I checked with these standoffs here. So I will be getting a lot more thrust out of my motors from this frame, which should be good. So hopefully I'll do a speed test when I've fully built it. So yeah, stay tuned for my next video where I actually put all the electronics onto this frame, solder the whole thing up, and maybe do a quick maiden flight. So yeah, see you later guys.